Hi everyone, thank you very much for watching this video. We would like to introduce here a series of tutorials that hopefully will help you to become a master of RapidMiner. This overview is a summary to highlight these tutorials. The material included in these tutorials is based on what we have learned from our customers about their critical needs, as well as the technical and business high insights released constantly and generously by RapidMiner. This series is by no means to offer you a comprehensive set of skills that will solve any problems you might be confronted with. Instead, we hope that by going through these tutorials, understanding and practicing the concepts, you will be inspired. To the extent that you will continue sharpening your skills and raising the levels of instinct and creativity in problem solving. Ultimately, your productivity and your team's productivity will improve. We will talk mostly on data preprocessing techniques on RapidMiner. It is one of the biggest challenges to our customers, and even more so with the increasing popularity of machine learning algorithms and their availability in programming libraries, and easy-to-use platforms and automata tools. Oftentimes, with a business problem in hand, we are, unfortunately nonetheless, dealing with a bunch of data sets that in no shape or form look as neat as those data sets provided in public for learning or research purposes or for just machine learning contests. With such a gap, we may not even be able to formulate the problems, let alone prepare the training data sets with potentially useful attributes, specifically at the right granularity level. Hi, my name is YC Lee. I'm an AI project consultant with Scientific Formosa here in Taiwan. I have been a consultant for the past 10 years. Before that, I have taught and worked first in the United States and then in Taiwan for more than 20 years. Just briefly, SFI is a company that represents RapidMiner in Taiwan since 2017, providing technical support as well as professional services. Actually, it has represented many popular software tools more than 30 years now and helped its customers through many digital transformation initiatives. You may have some questions or doubts about RapidMiner still, wondering what a machine learning platform like RapidMiner can help you and your team with. Allow me to draw a bigger picture here. We have some intelligent applications that seem to have a prediction model inside. In reality, such a model would be hosted by a server, more powerful than your notebooks mostly. And some smart people like you may have written programs to operate on the data and build a model for deployment. As a practice for building prediction models have become more and more matured, the task of data prep, training, and validation have been better defined. Unfortunately, the resulting code may suffer from readability issues and others, and the team was just not communicating well enough for reuse and to gain some return on the investment. To improve these problems and further facilitate the deployment of models, a machine learning platform like RapidMiner is to offer a cohesive set of compact building blocks along with easy-to-use graphical tools. At the end, both productivity and teamwork will improve, and the company can catch more business opportunities faster and better and stay competitive. Nowadays, we are very fortunate with machine learning platforms such as RapidMiner. Many tasks can be simplified, and the entry barrier has been so low that even a competitor with somehow inferior R&D competency may all of a sudden just jump ahead of us or take away customers that we have been trying so hard as a team or a data scientist. Let's see what the platform entails. Usually, people focus on nothing but design studio. And granted, it is where a prediction workflow or data pipeline is designed and then tuned. But a model is of no use if not hosted for operations. A server not only has more power for computing resources for bigger and collaborative jobs, but also serves as an API host to support business applications. The engine behind the studio and the server has a vendor's own in-memory optimization schemes that works well with other prevailing languages and tools. And the marketplace and the community forum, the ecosystem that users can share and even profit from by publishing vertical extensions. As for the near real-time scoring or prediction, a good example is a kiosk at the airport for luggage check-in, and where the upgrade options quickly popping out on the screen, right? And thanks to these high throughput and low latency of those lightweighted containers. So how can we leverage RapidMiner to solve all our problems then? Using RapidMiner is much simpler than coding, as we know, but take effort still. And learning all these operators would be a very daunting job, right? However, it is more important to understand the basics of operators. What I'm saying is that whenever we're using the operator, let's try to take time to read through its help documents, particularly the list of the parameters and also the tutorial that they have embedded there. And it would also help to check whatever other operators are in the same operator folder. Gradually, we will grasp the essence of these powerful operators, although we are just being exposed to a few of them. Right? That being said, we have unfortunately continued to see customers struggle to master the platform the way they like. And what are the reasons then? We would like to help here, so we have compiled these 6 tutorials, mostly from different data preparation perspectives. We have provided end-to-end scenarios to demonstrate the preprocessing techniques. So what are our motivations and objectives then? One of the key reasons, as we came to realize, is a lack of creativity and instinct that may have blocked our users from problem formulation and problem solving. Oftentimes, we do not know what attributes we can and should have for formulating a machine learning problem. By problem formulation in this context, we mean there is a clear statement that defines the problem and includes whatever attribute that should have been ready before training the model. Therefore, to leverage RapidMiner platform, our objective here are to highlight those concepts and the techniques associated with dataset transformation. Such knowledge will come in handy when we are presented with high-level but mostly vague business problems. It helps us to come up with different alternatives for the problem formulation and the formats of the data sets that are required for model training. An important reminder here we have is that there are prerequisites for these tutorials. The order of these tutorials is recommended as shown here, but we can take them in any other order, right? But what is important is that we need to familiarize ourselves with the usage of the tool itself first. And it is okay that the number of operators we have practiced is still limited, but these terminologies shown here should be very clear to us. For example, if we move from the top left, the operators, the repository, the data import tool, and the pull down menu to create repository and something else. And down there, we should be able to monitor the usage of memory and other resources. And the macros will list and track the value of the variables we are using. And to the main panel here, first process is where we design the workflow and or the data pipeline, right? And the next is the XML panel that has the equivalent XML statement to the process we are designing on the process panel. And this XML format is useful when we, and it's more portable when we talk to the community to ask others about our specific questions. And help is important. That's where we make sure we understand the parameters and make sure that we have some tutorial to do some demo to help us understand the particular operator. And to the right, the parameter list, I think, is the most frequently used part, where there's so many options for different kind of parameter for you to choose, right? And then we should also have a log panel so that we have some trace in more detail for the debugging purposes. And on the top, that under each tab, I think we should be able to find out the information for specific tasks we may have to do, right? And then lastly is that depending on the license you have design and the results, and then probably the turbo prep and the auto model and even deployment and others. This very first tutorial is to make sure that we can derive potentially useful attributes of the object at issue for exploration and training purposes. In the small example, the records available are actually at a lower granularity level than the level for the objects we are interested in, right? In other words, here we have 24 job records associated with 6 employees. And at the employee level, we would like to predict something on. First, let's add some additional columns for the job records. For example, duration and the starting age of each job, an indication of the work being the past or an active one. And then lastly is the job sequence numbers by the person. And we should be able to use quickly the RapidMiner operators to come out with a result like this with all the columns we like to have and the output records sorted by the person name. Then we are ready to move up the granularity level from jobs to the employees, right? For example, we like to add the average salary of each person. We also like to include the latest 3 job pay for each person. And finally, we like to have some statistics about the salary and the duration, job duration for each person. Again, using RapidMiner operators, we can quickly come up with this output with only 6 records and 1 for each employee. On the top, it's mostly the columns related to the latest job, and on the bottom, that will be then the salary, histories, and statistics, and on the job duration as well. And the repository shown here is what we used in a hands-on workshop, but it is rather straightforward. So you can build yourself or just gradually build them up while watching this tutorial. It looks simple, but it's not trivial at all if you really run through them and take the chance to learn all the operators that are involved. So after reading in the simple data set, right, we start manipulating some datetime, and you will also see the usage of macros to define the latest date you try to refer to. And this group into collection is where we can move up the granularity level from jobs to employees. And we can also do some aggregation, and the renaming operator is particularly useful to rename the system generated aggregation column names. And we probably have to practice some of this regular expression so as to handle these particular tasks well. And then we have this windowing and lagging, right? This is like a in time series case where next to the column of the current values, we try to add another 1 or 2 or 3 or more columns for the past values. And that's where we're using some of this lagging concept. And lastly, the join operator is to combine all the derived attributes together. Now let's move to the second tutorial. This particular data set is available from UCI repository. That's a University of California at Irvine campus. The data set is experimentally obtained with a hydraulic test rig. Each engine went through a test cycle of 60 seconds, and some sensors provide 3 readings per second, while others provide only 1 reading per second. And that's why we're seeing quite a number of missing value entries here. The label indicating whether the internal pump of the engine is leaking or not is provided for all the 2,000 plus hydraulic engines. And as some of you may have tried before, if we were to take this data set as is to train the model directly, first of all, the number of attributes will be very large, and then the result will be rather disappointing as well. But if we were to visualize these readings as waveforms, we might be alluded to deriving some of the attributes that are more interesting, right? Of course, we need to first normalize these readings, so for visualization and for subsequent model training. Again, the repository shown here is for our hands-on workshop. We have taken this material mostly from 2 of the RapidMiner workshop in the past few years. The instructors are actually very experienced, that they have provided many interesting ideas. Later in our tutorial, we will provide the links to these workshops so that folks can take a closer look to what they have presented. Here we first talk about the concept of object profiling. The objective is to predict if an engine under the test is leakage or not based on the profile we create here. And we will first show that the approach based on this profiling works out pretty well. Then move on to to the other approach that is recommended by the RapidMiner instructors. They were talking about that there might be concerns from the floor, the domain experts, and then all the operational folks. They would rather to have more faster and easier approaches based on more traditional, straightforward learning algorithm instead of the more complicated deep learning or gradient boosted tree type of models, right? So the proposal here is to just take the first 10 seconds of record and try to forecast the value for the next 4 seconds for an attribute that I have selected. And considering that attribute is more salient, it's more discriminating for classification purposes. And the result is not bad, even though at a slight expense of the a lower accuracy. As the original instructor was running out of time, so they finished there, and but we would like to take a closer look to really see how these forecasted numbers will play out, right? And we even question if we just use the actual value instead. The difference, of course, is that if we take the 10 seconds record to forecast the next 4, and then if machine is fast, we can come out the result 10 seconds into the test. But if we don't do the forecasting, instead we just take the actual values, 4 values to do the prediction, then we will have to wait until 14 seconds into the test to come out the result. But whatever case, we are just trying to take this chance to see the possible difference and also try to see if those forecasting values can be approximated by some coefficients and see if the result will be better. And that makes a whole tutorial quite interesting, and we get a chance to have a real exposure to all the time series type of operators that provided by the RapidMiner. What about the third tutorial? Sooner or later, people who are interested in using RapidMiner will run into SQL, the ubiquitous database language called structural query language. However, as popular as it has been, it is hard to deal with without a proper IT background. 2 years ago, in the RapidMiner workshop we held for the ICU professionals, we were asked to refer to Mimic3, a medical database for training material. The database is useful and provides in GitHub many SQL scripts that implement some important concept in medicine. And shown here is the Angus criteria of sepsis. It looks up into the ICDs, the International Classification of Disease, for infection groups, for diagnosis performed groups, or for the group that use mechanical vent, etc. While the participants of the workshops seem to be able to read such SQL scripts after a short tutorial, they were kind of hesitant to write a new one from scratch or modify the existing one. As such, even though RapidMiner allows user to embed SQL queries in the database operators, the participant would like to see if they can build a logically equivalent RapidMiner process and modify it whenever needed. Here is a quick look into SQL statements and see how they get complicated rather quickly. And first, it can use alias to include the same relation more than once. It can also use alias to simplify the name of the attribute and then involve different kinds of joins, and also use the partial matches against some attribute values, right? And then to group records into subsets and qualify some of the subsets with some criteria. and order the subgroups, and then for the output, generate some aggregation for each subgroup. Finally, it might be able to derive additional attributes. For example, we have two threshold values. And if the value is larger than a higher threshold, we label it as a good. Label this additional attribute as good, right? Or bad if it is lower than the lower threshold. Or fair if it is in between. Yeah. But syntax-wise, they are all logical statements that we can communicate with. I think people would agree with that. But at the same time, we also know what is difficult is actually the possible devils behind these logics, as we might, by mistake, introduce a lot of undesirable records, or we miss some important records, right? So the natural question is that why not just realizing such logical statements in RapidMiner then, where we can use all the operators instead of coding, and we can check the correctness by checking all the intermediate results. And also it is better documented, right, with a graphical tool. To access the full Mimic3 database for the workshop, we need to pass a number of courses mandated by the hosting organization. Luckily, a miniature of this Mimic3 is also provided for everyone, just for the demo purposes. And in this tutorial, we use this demo databases for the whole workshop, right? And we took 3 SQL statements and implement them as RapidMiner process. It is interesting and quite helpful to see how the corresponding operators are being used. And while doing so, we will learn a lot about the data sets, how can they get manipulated and transformed in the RapidMiner. The scenario discussed in this tutorial 4 is actually a challenge from a local power company 2 years ago. Its team of mostly statisticians would like to see if RapidMiner can help them. The training data consists of nothing but more than 35,000 hourly power consumption values from year 2017 to 2020. The request is to predict for the forthcoming weeks after our visit. It's from 11th to 18th. And the customer then will check our forecast value against the data when it's available. And as a typical proof of concept effort to be completed in a couple of days, the customer did not mention or ask for further specifics. So we just tried our best, right? And as you may know, from version 9.8 on, RapidMiner has included a rich set of time series operators as part of the system. In other words, it's no longer just an extension from the marketplace. In this tutorial, instead of a traditional statistical-based approach, we have formulated the problem as machine learning problems. It is quite interesting to see how the problems can be formulated and how the data can be prepared or augmented with additionally derived attributes. Partly because we have followed this time series functionality of RapidMiner rather closely, we were able to respond to the customer's request in 2 to 3 days. We showed to the customers the result of all 192-hour hourly forecast with various charts. And shown here first are the hourly changes for selected days. And the days are colored, right? And similarly, we can draw some chart just by changing the axis and the the coloring groups. So this would be the daily changes for the selected hours that are colored. Of course, with machine learning approaches, we not only need to show the forecast values, we also have to show the performance numbers, right? And only through performance numbers that we can objectively judge whether the model is doing its job or not, instead of just looking at and feeling about the forecast values. And for all these 192 regression values, we actually have 192 regression models. So each model has its corresponding performance number. So looking at this chart here, the curves are actually the performance numbers. So you will see that as low as 3.5%, that will be the performance number for a more static type of distribution, like in the early morning hours. As for the lunch or napping hours, that fluctuate a little bit more, so the performance number gets to as high as 5.5% or higher, right? And by the same token, we can show the chart with different axes and the different color groups. RapidMiner does have a comprehensive set of operators for both statistic-based and machine learning-based approaches for time series problems. And this tutorial will first talk about both. And moving a little bit into the flavor of machine learning by using operators like forecast validations and with the optimization parameters and apply forecast, right? Once we are clear about that and have some feeling between the difference of the two, we will come back to visit these particular data sets for the power consumption, right? And we will show an end-to-end workflow with preprocessing, training and validation, and the forecast, right? We treat it as a multivariate, multi-step load forecast. And some of you would say, well, multi-step is understandable, and as we are forecasting multi-labels, right? But the input data is only a one-dimensional time series data. How can we call it as a multivariate, right? From statisticians, of course, that multivariate does make a big difference from univariate, as the theory or whatever theoretical stuff will be different and gets more rigorous. But for machine learning type of approach, this is rather nature, right? And as you can see that we are just looking at the observation and try to do prediction. These observations can come from different sub-observations. One sub-observation can be composed of nothing but the values we try to see the trend, right? But we can have other components, for example, the weather information. Even though in this particular tutorial we did not go out to grab the weather information, but we actually try to use some statistics to beef up another part of the observation. For example, we can calculate the weekly average, monthly average, or daily average. So for example, I can say, look at today as a very last observation. I would like to add also the weekly average for the previous 3 weeks, or the daily average for the previous 10 days, right? So these can easily become a multiple variate forecast problems. Let's talk about tutorial number 5 then. Text analytics has been a popular area for machine learning, and it is also a powerful functionality in RapidMiner. But this tutorial 5 will be the only tutorial presented in Mandarin, as it is of local importance to folks in Taiwan. There is a missing link for users in Taiwan to use RapidMiner for Chinese text analysis, more specifically, the traditional Chinese, right? The reason is mainly that text segmentation means quite differently in the two languages. For example, typical delimiters will segment the English text into words, whereas such delimiters only break a Chinese text into sentences. So we need some specific segmentation tools to break this text into tokens, and hopefully that the remaining operations will be very similar. Let's first assume it is feasible to insert an operation to segment traditional Chinese text into strings of tokens before typical document processing. Right? We are hoping that the process followed here will work for both English and Chinese text. For basic text analytics, once the text is segmented into tokens, the remaining operations such as stop word filtering, dictionary lookup, and vectorization would indeed look almost the same. Right? We can then take full advantage of RapidMiner to start forming the workflow and try to tune the whole process by trying different sub-processes and learning algorithms. For example, we have two different methods involved here for comparison. Right? I'm not an expert in this particular area. What I try to emphasize here is that we do know for text analytics there are quite some number of parameters that are very sensitive. So on the whole process, sometimes things like the size of the dictionary, right, and the stop word you're using, and not to mention the algorithm we'll use as VM or other learning algorithms. So we can take advantage of RapidMiner and try to look and make some comparisons so that we can get closer to a better solution of the problem in hand. This tutorial first quickly review the basic concept of document vectorization and shows how to establish a prediction process using RapidMiner. We first go through this machine learning case for the movie review predictions, right? And then we move to the traditional Chinese case for this same use case. It will be interesting to find out not necessarily every algorithm you are familiar with can work equally well here. And you might be even surprised at the performance differences. Then we move to talk about two of the RapidMiner's operators, namely getPage and cut operations. They work equally well for English and Chinese when try to crawl some media news, right? And we will then finish it up with a simple multiple case classification of traditional Chinese media news. And at the end, we will come back to just revisit this Chinese segmentation case where some of the parameters for searching possible tokens can make quite some difference. And we will review this process and point it out exactly the difference that some of the parameter would make. This very last tutorial, tutorial 6, is not really about data preprocessing, even though that is involved a little bit, right? Instead, we are talking about what a well-trained model can do other than predicting on new observations. If you are puzzled by the question still, think about a situation where we have a prediction model in a factory to predict yields and other outputs, and it started shooting out alert since the model has predicted something wrong, be it minor or critical. And at this point, the operational people would need to take some corrective actions. For example, adjusting some controllable valve to a different degree, right? So we are actually asking the model or the system for corrective actions rather than predictions. And this is prescriptive analytics, if you will, instead of predictive analytics. It's shown here is this example of the petroleum bitumen production, a simple case here. And we have some output attributes such as yields and income or etc. This business goal try to achieve, right? And then we also have some controllable settings here, just like a condenser temperature, steam flow, etc. And to the right, we have something external, or consider them as a non-controllable features, such as outside temperature or outside pressure, right? The use case here is to adjust some of this controllable valve for the best yields when actors are called for. For example, tune some of this condenser temperature, etc. And it would be terrific if we have a dashboard, as we will show here. Here we first see the fixed parameters, such as the temperature or the pressure. Then the current readings for those adjustable parameters will be shown, right? And then, of course, the system can predict what kind of output we may be able to get for this batch. Meanwhile, some optimization work is taking place behind the scene, so as to suggest what possible adjustment we can make in order to make the yield or some other desirable outcome, right? We can see how much this output will be improved. And finally, we can also see the trend of the comparison along the way. All the important concepts and operators discussed in this tutorial will be centered around the notion of model interpretability. As some of you already know, RapidMiner has addressed this problem very well. It is based on the Lime algorithm, and RapidMiner has since made a lot of improvement for practical reasons on this particular algorithm, right? It is the local interpretable model agnostic explanation. As the name stands, right? And we can interpret the prediction behavior, and we can simulate the model with changes of attribute values. And lastly, we can optimize the attribute values for best predictions. This prediction can be higher classification confidence or better regression results. Then we will show some use cases in two different modes. The first one will be the interactive mode, and that is on auto model, right? Where we just follow steps interactively, right? We can first take a look at the generic weight that is done by correlation between the input and output. Then for each algorithm we execute, we can see the model specific weights. And then we can even see the highlights of the feature importance for each prediction. And at the end, we can do this interactive simulate and optimization, right? On the other hand, the other mode is the automatic mode. It is very important. As long as we want to make our model and our optimization operationalized, right? By that, we are talking about having a RapidMiner process running on the AI server and hosting some application where the recommendation can be constantly made and try to reach a better results. And talking about this RapidMiner workflow, of course, we have to use operators explicitly, right? And particularly the last two, prescriptive optimization and the prescriptive analytics, are the two operators that will do the optimization. And the first one is available earlier through this extension on the marketplace. And the later one is a new one and improved one by the RapidMiner itself. So we will see how these operators can be used to support a automatic process. So we just briefly introduced the 6 tutorials we have here, and hopefully soon we can make them public available. And once ready, you will see the video links here below, right? And of course, we will improve them or add new ones along the way. Quickly, the first tutorial is about granularity levels, where we would like to add whatever necessary attributes at the right level. And the second one is to turn the sensor data that are time sequenced data into useful profiling kind of attributes for problems like classification or regression. And third one is to closely examine the equivalence between SQL statements and RapidMiner data pipelines. And we can learn a lot about data transformation by going through this tutorial. And the fourth tutorial is to turn a time series analysis problems, a more traditional one, into the machine learning based type approach, where we will demonstrate a multivariate, multi-step type of forecasting problems, right? And the number 5 will be presented in Mandarin, I believe. It is about traditional Chinese text analytics, where I will try to fill in the gap by using a Chinese segmentation tool. And the very last is about it's about model interpretability. And 3 features: explain, simulate, optimize, will be demonstrated in 2 different modes. One is interactive mode on the auto model, and then the other one will be the automatic mode that will be through a data pipeline and the workflow on the RapidMiner Studio, right? And the latter will be very important for operationalization purpose. So quickly, we have these lectures mainly to demonstrate important data preprocessing techniques, and we hope that they are interesting and inspiring enough to get everyone here going, so as to become a master of RapidMiner in the near future, if you're not one yet, right? So we will soon make them available, and please stay tuned, please. And thank you very much for watching this video, and we will see you soon. Thank you.